Hi, I'm Jacob Kellum,
And I'm Cooper Kelly.
and we will be presenting on the science behind nuclear energy, as well as the nuclear energy industry, and other general facts included in this topic. Some of the subtopics that we'll be overviewing in this presentation include the history and development of the nuclear energy industry, the current state of the nuclear energy industry, and also future developments in nuclear energy.
All right, without further ado, let's get into the presentation. Okay, so first we're going to start with the history and development of nuclear energy industry as a whole to sort of give an idea of how the idea of nuclear energy came to be and the discoveries that really helped push the industry along as it was developing. So nuclear energy as a concept as a whole was developed over the course of a couple centuries with a series of discoveries made by brilliant scientists. So some of the first beginning significant discoveries was the discovery of uranium, a radioactive metal, by Martin Klaproth in 1789. Klaproth was a German chemist. A century later, ionizing radiation was noted for the first time by German scientist Wilhelm Roentgen in 1895. A year later, radioactivity was coined and observed for the first time by Pierre and Marie Curie, and their discoveries would later lead to additional findings about the types of interactions and damage that radiation can do to both inorganic and organic matter. In 1902, Ernest Rutherford made some findings on the modes of emission of radiation of both alpha and beta particles. Alpha particles being composed of 2 protons and 2 neutrons, overall being positively charged, and beta particles usually taking the form of an electron, which is negatively charged. Significant discoveries were made when Enrico Fermi and Niels Bohr both separately made significant breakthroughs in nuclear fission, the process of which is shown in the bottom right corner. Additionally, uranium-235, an isotope of uranium, was found to be highly radioactive because of its slow-moving neutrons compared to the more standard uranium-238. Lastly, the idea of critical mass, which is the mass that a collection of atoms must reach in order to perform a self-sustaining fission reaction, was discovered by Francis Perrin in the year 1939. Next, we'll discuss historical events that nuclear energy had a large part in.
There have been several historical events within the last century that have been related to nuclear energy, and a few in particular have really demonstrated the progress that has been made within nuclear energy research. One of the most notable advancements in nuclear energy research was the Manhattan Project, which was a World War II effort led by a team of American scientists to develop the world's first atomic bomb. Once these scientists successfully developed this nuclear weapon, the bomb was first tested in a remote desert in New Mexico in 1945, and this testing was named the Trinity test. 1 decade after the Trinity test, the first nuclear-powered submarine was created and named the USS Nautilus. This breakthrough allowed submarines the capability of traveling at much higher speeds and longer periods of time than were possible before. The U.S. Navy went on to have 26 operational nuclear-powered submarines within the next 10 years of the USS Nautilus. Up next, we will address the current state of the nuclear energy industry and take a look at some of the advantages that nuclear energy provides when compared to other sources of available energy. Nuclear energy provides several advantages, but comes with a few potential drawbacks as well. Nuclear power plants take a lot of money to build initially, but they end up saving money with minimal operating costs in the long run due to them requiring small amounts of fuel that usually last several years. They also give off little to no carbon dioxide emissions and generate very little waste as well, because any waste that is created usually is able to be reused in the nuclear energy process. Nuclear power plants are also capable of providing nearly an endless amount of energy. One downside is that nuclear power plants are capable of incredibly harmful catastrophes such as the Chernobyl disaster that happened in Ukraine, but these events are very unlikely as nuclear power plants are very safe and controlled.
When you analyze nuclear energy versus other sources of energy that are used in society today, you'll find that there are many advantages that nuclear energy has over those other sources. Although there are also some downsides too that need to be discussed and I think analyzed as well. First off, as you can see in the diagram on the right, nuclear energy provides a much higher safety rate, that being much lower death rate per terawatt hour of energy produced than other sources. As you can see, brown coal, and oil have incredibly high rates, greater than 1, while nuclear has a much lower rate than 1. It is very cost efficient compared to both coal and petroleum, with nuclear electricity being roughly 6.6 cents per kilowatt hour of energy, with coal and gas being 6.2 cents and 6.5 cents respectively. Of course, this is assuming that technology risk premiums that are associated with nuclear energy are lowered in the future as, the industry becomes more widely accepted and insurers view it as a more risk-free source of energy. According to a September 2012 issue of Energy, an energy research and engineering journal, the capacity factor of nuclear power plants is significantly higher than most other sources and also higher than coal power plants, with nuclear power plant capacity averaging roughly 90%, while coal sits at 85%, and other sources, hydroelectricity, is at 52%, offshore wind power plants at 34%, solar thermal energy at 18%, and photovoltaic energy at 24%. A downside of nuclear energy is that fuel can take significantly longer to process, but it requires much less fuel to maintain energy production over the years than coal, for example, which requires a continuous supply of coal for the energy to keep being produced. Lastly, nuclear power plants produce significantly less CO2 per unit of energy produced than coal and oil and other fossil fuel industry power plants, making it much more sustainable for our environment.
Finally, we will address the future of nuclear energy, including topics such as improving current nuclear power plant infrastructure, cost reduction of the nuclear energy industry as a whole, and also the implementation of nuclear fusion, a newfound method of applying nuclear energy.
When considering the future of nuclear energy and how it can be made to better fit society's needs, it's really more of a question of how can the world's economies be altered to better fit the nuclear energy industry. It's our belief that nuclear power plants will continue to evolve and grow, offering new evolutionary designs of reactors that will produce less waste and have higher energy efficiencies. As such, we believe that economies will grow to favor nuclear energy and it will be looked more highly upon by the world's leaders. According to an April 2019 issue in the Journal of Nuclear Engineering and Radiation Science, there are 3 steps that economies can take in order to favor nuclear energy. Those being optimizing capital, operating, and generating costs of plant output, minimizing cash flow risks, and thirdly, determining the proper build profile of unit and plant numbers and creating outputs to match customer needs. Lastly, we want to talk about nuclear fusion as an alternative. There's not a streamlined way that is known to performing nuclear fusion and is much more dangerous than nuclear fission. However, the potential energy output it offers is exponentially higher. So it is very exciting to consider. Thank you for watching.
We hope you enjoyed our presentation and that you're able to learn more about nuclear energy and the industry surrounding it.